data set by specifying the hue and then grouping it, and then we will also make a strip plot of sepal length, sepal width, petal length, petal width grouped by species. We'll generate a swarm plot, generate a violin plot, and the rest of the items that I've already mentioned in this screen will cover. So first of all, what we'll do, we'll import the data set, and then we'll also import the necessary libraries. So what's the content of my data set? It has how many columns? 5 columns. ID will not be of use. So sepal length, sepal width, petal length, petal width. It is of the iris dataset. Just for the understanding, this dataset consists of 3 different type of species: Setosa, versicolor, and virginica. Iris setosa, iris versicolor, and iris virginica. Okay, these are the different kind of types. So well, iris is a flower, and this is a different type of petal length and petal width that we are referring to. So let's start. First of all, we will execute the very first item in the list is number 1, Seaborn lmplot for plotting the linear regression. So in that case, what we'll do, we already have the object of Seaborn sns.lmplot, and then we will give, suppose x is equals to sepal, comma, y is equals to sepal width, comma, data is equals to iris. So you can see there is a slight negative correlation between sepal length and sepal width, because once sepal width is increasing, sepal length is decreasing, and vice versa. So now similarly we will see the linear regression correlation between the petal length and petal width. So this is positively correlated, and okay. So our task number 1 is completed. Now we'll start with our task number 2, generate a residual plot. So here what we'll do, here we'll simply use the resid plot. There is an object of Seabourn resid plot, and then we will simply pass this values like x is equals to iris, sepal length, sepal width, comma, color is equals to we'll give red, and we'll give marker so that will be visible properly. So, okay, marker is not required in resid plot. Okay, we can see the residual plot of like the graphing a map between a sepal length and sepal width. Now similar thing will execute between the petal length and petal width. So you can see, okay, so task 2 is completed. Now what we'll do, we'll generate a scatter plot. For that we have to simply give plt.scatter, and then between the same, for plt.scatter we will simply map it between the iris sepal length, sepal width, petal length, petal width. Marker to make it visible. Okay, so we can see the scatter plot. Now if we want to see the how the scatter plot is scattered for my petal length and petal width, that is, I'll give an assignment. If you're following this, you can download the dataset and try the how to plot a scatter plot between, draw a scatter plot between the petal length and petal width. Now what we'll do, we'll draw a different level of curve for degree 1, degree 2, degree 3, for all those kind of things. Okay, so for suppose if you want to draw a regression plot for order 1, then we'll do sns dot regression plot, and then we have here, right? Okay, what we need to pass, we need to pass x is equals to, we'll copy this, data is equals to iris, and then we will give the label, name of the label, what it should be, like order 1, and what is my equation, what is the degree of my equation is first order. Suppose in this case order is equals to 1. Okay, if we execute this simply, we get the line like this. And if we execute these two lines, okay, now what I will do, I will simply increase the order and I'll change the name. You can say it is curved. Similarly, if I give the order 3 and if I give here order 3, so this is curved. Now what I will do, we will plot it all at a time. Okay, you can see my blue curve, my red curve and my yellow curve based on the degree of orders. So if anybody is following this, they can plot the graph till whatever order, like 4, 5, and also they can you can plot between the petal length and petal width. Okay, so task 3 is also completed. Now we'll start with task number 4. Plot a linear regression between the variable of iris data set by specifying the hue. Hue is kind of grouping. Okay, for that we'll give sns dot lmplot, and then we'll give x is equals to sepal length sepal width comma data equals to iris comma we will row it based on the species. Okay, we have to give hue here. One mistake which I did, it should not be quotes. Okay, so you can see like the data how it is being formed for the different species, right? For red it is iris setosa, for blue it is versicolor, and for green it is virginica. Now we are done with, so as I have mentioned, like you can try out with petal length and petal width. Now we'll start try the task number 5. We need to group it. Okay, yeah, so we'll do the same thing, just in shift and okay, we will do here, we'll give just row is equals to species. And now if you see like a different map or a different figure is like created for each type. Like this is for setosa, this is for versicolor, and this is for virginica. So task number 5 is completed. Now we'll check how to make a strip plot between sepal length, sepal width, petal length, and petal width. So petal width, I'll give a task for you to complete. Okay. So what we'll do, we'll create a subplot plt dot, which I've already taken care in my previous session. How to create a subplots and plots, everything I have shown there. You can follow that. And then here sns dot st strip plot. You need to give x is equals to your species. Based on that, we'll take, and then y equals to suppose sepal width comma data. Obviously we have to give iris x3. Okay, so it will 2 into 2 matrix will be formed. Okay, yes. Yeah, my 2 into 2 matrix is formed with Setosa Vajikana. Now, in this, like what we'll do, we will pass the something called jitter is equals to true. So this will not be as compact. It will be like a bit. Wish. So you can see like how data is being spread in this line, but though it is still based on this species, but you can see it visible how is this is a different way of representing your data with jitter. So task number 5 is also completed. I'll say task number 6, right? This was 6. Now we'll move on to task number 7, which is generate a swarm plot. So for generating a swarm plot, it's very simple. PLT dot or simply you can give SNS dot SW swarm plot, and then you need to pass based on some axis. Like in x-axis, what do you want? Species, CIS species, and in y-axis you want your y-axis is equal to your sepal width, suppose, comma data is equals to iris. Okay, now this is how your swarm plot is formed. You can try out with the petal length and petal width, and also the sepal length. Sepal length I try. And even you can try out this all the 4 figures of swarm plot in a subplot. So task number 8 is to create a violin plot. Task number 8 is to create a violin plot. That will be like very simple sns.v violin plot, and then you need to pass the same your violin plot is created. The next task is create a joint. So for creating a joint plot, we will simply give sns.joi joint plot, and then we'll give the data as it is. Okay, but this is not making much sense. So what we'll do, we'll change this. Yeah, this is what I wanted to show you. The joint plot, the full distribution, my Pearson coefficient, and my probability value, p value. That this is what we can get. Now again, if we want, the next is the pairwise joint distribution. For that, it will be SNS dot say joint plot, and then you need to give kind is equals to this. Okay, you can see the distribution of your values, and this is the full distribution. This is nothing but it's a residual whatever what we get when our model is created. This is pairwise. This is one of the important graph which we should know. Pairwise distribution is very important. It will give you the holistic view of your all and each and every field. If you use pair plot and just simply pass the data set, and now you see the magic. It gives regression, like the scatter plot of each and every item with respect to other. Like obviously ID first column is not required. So what we can do here, we can remove the first column and then we can plot. So this is how we can get the pair plot, and we can get the relationship between each and every field. Like you say, the relationship between the petal length and the sepal length, petal length and the petal with each and every field you can get, whether it's a positive correlation or a negative correlation between each and every. Task 11 is done. Now we'll do heat map. Heat map is also one superb thing that helps you to get the entire variance of not variance, correlation between each and every field. So SNS dot heatmap, and then you need to pass, because the correlation that we are working with here, line with the line of the DL. This is, we have already got this error showing it is not there. Okay, here we get the correlation between each and every field. Like if the correlation between sepal length and sepal width is negatively correlated, and again sepal length and petal length is positively toward whatever value is towards one. Like the value of this correlation between -1 and +1, whatever value is towards -1 and +1 is strongly correlated, and whatever value is around 0 is, or 0 is very like not correlated. Now I think I have missed one. Yeah, pairwise distribution by species. First thing, okay, that thing was the task number 11. What we did was simple pairwise joint distribution. So now we will give again. So this we will do SNS dot pairplot iris q is equal to species and kind is equal to regression. So this is how we get the output of this pair plot if we give the kind is equal to regression and u is equal to species. Now the next is the box plot. The box plot is quite simple. We know SNS dot box plot, we need to pass x is equals to species comma y is equals to data is equals to iris distribution. Now suppose if you want to draw Andrews curve, now what is the next task here? kdeplot. How to draw the KDE plot? kdeplot is helpful during the univariate, like finding the univariate relationship, okay, and which creates and visualizes a kernel density estimation. It will be simple. SNS dot Dataset grid, and then you need to pass iris this is our, give a smaller size here. Okay, so this is our KD plot. Now the task number 14 is also completed. We'll check. We are left with two tasks, which are like Andrews curve and the Radviz. So how do we Andrews curve actually involves like using the attributes of the sample as coefficient for the Fourier series. So how we will use this? We'll use we already have our so this is the Andrews curve, and the next thing is the last thing is the Radviz. This is also kind of like finding multivariate visualization techniques in pandas, which is like RADV I said, and it puts each feature as a point in a two-dimensional plane, and then simulates having each sample attached to these points through a spring weighted by the relative value for this feature. So how does it work? Again, we'll say the same thing. Okay, so this is how we can get the different Radviz curve, or like the graph for it. So this is how like we can use iris dataset and plot the different kind of uh, figures. Like We can use Seaborn lmplot, residual plot, swarmplot, Violin plot, scatterplot. We can do a pairwise distribution. We can do Boxplot. We can do draw heat maps, Andrews curve, Radviz, and several other. Okay, so thanks a lot for watching this session. If you feel this video is helpful, please press the like button and also subscribe to this channel. Okay. So I'll see you in the next video. Thank you.